Ladies and gentlemen, we are talking about graphing. You have Cornell notes that are probably pink and look something along the lines of this that should be folded per my instructions. So this video is going to be distance time graphs only. So if you're looking at your foldable, it is the left side. So it'll be the outside left and the inside left. One thing I would like to point out is there are two basic ways that we will look at graphic for the motion of the object. And so for today, we're going to be looking at distance time graphs only. It is very important, ladies and gentlemen, that we look at the y-axis. That is the most important one. So for example, remember the y-axis is the vertical axis. Okay, so every time you look at a graph in science, I need you to circle the unit on the y-axis. If you don't, you're going to miss something very important because what's on that y-axis determines how we read the graph. Ladies and gentlemen, we are starting with distance time graphs. It is the outside left of your foldable, and let's start. That first box there says a distance time graph tells us how far an object has moved and how long it took to move. And so basically with distance, I like to think of starting point and a destination away from the starting point. All right, the next box on that outside left is going to be, you're always going to have time plotted on your x-axis, and then the further right, the longer the time from start. So basically it looks like this. Right here at the origin, that's home. Okay, so your beginning time of 0 is going to be at the origin, and let's say it goes all the way up to 60 minutes or seconds. So you got 0 to 60. Okay. Your last box on the front is going to state that distance is always plotted on the y-axis. The higher the graph, the further from start. So again, here is home. And if I'm looking at my x-axis, I've got 0 to 60. These are just imaginary numbers. It could be anything. Sometimes they'll label the graph with the actual unit, sometimes that they won't. But what this is focusing on our y-axis, which I want you to circle the unit on the y all the time, home is at the origin, and then I like to think away from home. Okay, so when I'm talking about distance, I'm talking about my distance in reference to home. All right, go ahead and go into the inside left. We're on that top box. You see the picture that looks like this. Okay, that's a distance time graph. I always want to focus on what my y-axis is, so I'm going to go ahead and circle it. So I'm looking at distance. You want to remember that the origin is home. I'm going to just put an H for home. And then up here at the top, I'm going to be away from home, so wherever the finish line is. All right, so let's go ahead and fill in our blanks. The first blank is that a straight line on a distance time graph means that there's no acceleration. And by straight line, we mean straight diagonal. Okay? And the motion is constant. What you will want to remember about constant motion is that the speed and accuracy of the motion is the same. Okay? So, I've got Batman here. Okay? And he is going to demonstrate with our start and finish line what this would look like. So, the line is straight. So, let's look at it here. This is home. So, Batman starts at home, and then over time, he ends up away from home, wherever he needs to be. So I'm going to start him at the starting line. Now it says that there is no acceleration, which means there's no change in his speed. So his motion is constant. So he's at the starting point, and he's going to walk the same pace till he makes it to his destination. So he is walking the same pace until he makes it to the finish line. Alrighty, so now we're back to the second inside. So it's going to be the horizontal line. Remember, horizontal, it goes from left to right, like the periods do on the periodic table. So again, on my y-axis, I have a distance time graph. Okay, home is here at the origin. And remember, away from home is going to be here at the top of that y-axis. So I have a straight horizontal line. Now let's look at this. I'm a horrible tracer. I do apologize about that. It's on an iPad. Okay, so we're talking about Batman again. Okay, home is my starting point. A is my finishing point. So if I look at here, should Batman be at the starting point? No, he shouldn't. He's standing somewhere in between the start and between away. So where do I need to put him? He doesn't need to be at start. He doesn't need to be at finish because he's not up here and he's not down here. He's somewhere in the middle. And what is he doing over time? He is standing there the entire time. Batman has not moved. So for this entire 22 seconds, Batman is standing at 10 or so meters. Let's go ahead and fill in those blanks. A horizontal straight line means the object is at rest. Time is increasing. There is no change in location. So Batman is standing in between the starting point and in between the finishing point, and he has not moved. All right, let's go ahead and look at that last empty box there. Okay, we're focusing on a curving line. So let's fill in the blanks. A curved line on a distance time graph means there is an acceleration. The motion is changing. So remember, acceleration is any change in motion that's speeding up, slowing down, stopping, or changing directions. So let's go back to identifying where Batman is on the graph. So remember, the origin is at home. Up here is away from home, wherever he needs to be. So clearly Batman starts here at home. And curved line says that there is an acceleration, so there's a change in his motion, particularly with his speed. So Batman starts here, he's doing okay, and then he speeds up. Look at how the slope of that line increases very quickly. So it looks something like this. Here's Batman at the starting point. He's walking, he's walking, he's walking, he's walking. And then he speeds up to get to the finish line faster. He made it to the end up here, but in less amount of time than how he was walking when he first started.